Okay, we were on number 16b when time ran out of the video. We were finding the electrostatic force that was acting on the electron. So we were using KQQ over R squared. So K was 8.988 times 10 to the ninth. The two Q's were the electron and then the charge on the nucleus, which was just a proton. And then the R we found in part A, 4.7635 times 10 to the negative 10 meters squared. Okay, and so when you do this, you should get an FQ of 1.01656 times 10 to the negative 9 newtons. Okay, once you get that, then part C says, find the centripetal acceleration of the electron. Well, the electrostatic force, and for those of you not in physics right now, don't panic. I already said I wouldn't do this to you. But those of you that are in physics right now, you're learning the centripetal force. So FQ is really the centripetal force. And back earlier in this course, all of you, we learned that centripetal force was equal to mv squared over r. But centripetal acceleration is just v squared over r. So FQ is like the MA, or the F net. And so FQ is equal to MA, where the A is the centripetal acceleration. And that's what it's asking you to find. So AC is just equal to the force you just found divided by the mass of the electron. And one more time, I'm going to say, for those of you not in grade 12 physics this semester, do not panic about this. I will not do this to you on a test, okay? And so when you get but the rest of you that are in physics 12, this should be making sense to you. So you get your centripetal acceleration to be 1.116 times 10 to the 21 meters per second squared. That's a pretty good one. And then the next part wants to know the orbital speed. So we know centripetal acceleration is equal to v squared over r. So v squared is just going to equal the centripetal acceleration times r. So that 1.116 to the 21 meters per second squared multiplied by the r we found earlier, 4.7635 to the negative 10 meters. And remember, that's v squared. You then have to take the square root. And when you do, you get 7.2911 times 10 to the 5th meters per second. Okay? So again, one more time, don't stress about 16. I will not ask you one like it. The others? Yes, I would. E equals mc? Yes. Finding the energy level? Yes. But not this guy. All right, number 17. Hydrogen atom has an electron in the n equals 2 level. So if it's in the n equals 2 level, then En is equal to negative 13.6 over n squared. So negative 13.6 over 2 squared. So E2 is going to be negative 3.4 electron volts. I suspect we're going to need that at some point. A photon with a wavelength of 332, so the wavelength of the photon is 332 nanometers, and it says that it strikes the atom, show that the atom will be ionized. So to be ionized, the EP, which is equal to EF minus EI, the EP would have to be, remember, final to be ionized is 0 electron volts, and it's starting at 3.4, so negative 3.4. So to be ionized, EP would have to be 3.4 electron volts or bigger, right? So this is the energy needed, or this, in other words, is the work function or the ionization energy. And remember, we talked about that the other day. So what we need to find out then is this photon coming in, is its energy bigger than equal to or bigger than 3.4 electron volts. So first do C equals F lambda. So F is equal to C over lambda. So 2.9979 times 10 to the 8th meters per second over 332 times 10 to the negative 9 meters. And you get a frequency of 9.0298 times 10 to the 14th hertz. Once we have this, we can now find the energy of the photon coming in, HF. So 6.626 to the negative 34 joules times 9.0298 to the 14th hertz, and you get an EP of 5.983 times 10 to the negative 19 joules. But of course, we're going to need it in electron volts to compare it to 3.4, so divide that by 1.602 times 10 to the negative 19 joules per electron volts. And when you do, you get 3.7348 electron volts. So part A, will it be ionized? Yes, because the EP that's coming in is greater than the work function. Part B says, when the atom is ionized, assume the electron receives the excess energy from the ionization. What will be the kinetic energy of the electron? In other words, we're back to our good friends, good buddy, EK max is equal to HF minus WO. So EK max is equal to, we just did the HF, 3.7348 electron volts. We did the WO up there, 3.4 electron volts. So EK max should be equal to 0.3348 electron volts. And I don't know that it asks it for you. Oh, in joules it does. So then multiply by 1.602 to the negative 19 joules per electron volt, and EK max is equal to something like 5.3636 times 10 to the negative 20 joules. Okay, so there are your homework questions from the other day.